satellite, which was given before. It's 1,000 kilograms times our g of 9.71. So that's pretty easy, right? We picked easy numbers. We need a calculator for that. That's just what? 9,710. What are the units? Newtons, right? Next, we're going to try to figure out what's called the orbital speed of the satellite. How fast is a satellite flying around the Earth here at 20,000 kilometers above the Earth? So how are we going to figure that out? This is kind of tricky here. So the problem is we know the radius, so we could find the distance around, right? 2 pi r, but we don't know the time. So the trick is we have to use forces in this case. So what's providing the force to hold the satellite in orbit? What's that called? Yeah, what's holding it in orbit is gravity, right? So depending on the type of orbit you had, literally gravity is like the string pulling this thing into a circle. When we had race cars, right, it was friction on the tires holding the race car in a circle. So in this case, gravity is like that giant string of rubber band pulling a circle. So the force of gravity is the centripetal force, which is mv squared over r, right? Is the way we picture that there. So in this case, we found the force of gravity, 9,710 newtons. That's going to be equal to the mass of 1,000 kilograms times the velocity squared over the radius, which was 42 times 10 to the 6. So how do we calculate this? We do a little bit of algebra, right? We have to first multiply both sides by the bottom. So we multiply that by the radius of the orbit, 6.42 times 10 to the 6. Then we have to divide that by what? 1,000. And then how do you get rid of the squared? Take the what? Take the square root. And here's a little trick. If you do second root of your previous entry, that'll substitute that in. And we get an orbital velocity of